So good evening everyone. So we'll try to start our session. Let me share my screen. I hope my screen is visible. Please let me know in the chat box. Okay. So in previous session we have completed with logical operator, right? So we will try to cover all other operators now. Okay. So the next operator is unary operator. Okay, unary operator. So why we are using this unary operator? Why we will go with this unary operator? Okay, because it is used to increment or decrement a numeric value. Okay, basically the unary operator is used to increment. Okay, so to increment or decrement a numeric value. Decrement a numeric value. Okay, so if there is a numeric value, in order to increment or to decrement that value, we will be using the unary operator. Okay, in unary operator, again there are two types. Okay, first one is increment operator. Okay, and the second one is decrement operator. Okay, so first one is increment operator. So increment operator is used to increment the numeric values. Okay, so it is used to increment the numeric value. Okay, to increment the numeric value. So coming to the decrement operator. Okay, so the decrement operator, it is used to decrement the numeric value. Okay, it is used to decrement the numeric value. Okay, so in this increment and decrement also, again they are divided into two types. Okay, in increment there are two types like pre-increment. Okay, pre-increment, and the second type is post-increment. Post-increment. So what is this pre-increment? Okay, so by using this pre-increment, first what we will do means, first we will access the value. Okay, later the increment of the numeric value will happen. Okay, so first the value is printed or accessed. Okay, the value is accessed, and later, so pre-increment, right? So this is for post-increment. So in pre-increment, first the numeric value is incremented. Okay, incremented. Later, okay, later the value will be accessed. Okay, coming to the post increment, the name itself it is saying post increment means it will increment later. Okay, so first we will access the value Okay, and later the numeric value will be incremented. The numeric value will be incremented. Okay, so let me show with the example. So if you see here, okay, so let me erase this first. Okay, so I am declaring a variable. Let me declare a variable. Okay, so I am declaring a variable like int value is equals to 10. Okay, so what I am trying to do means I am trying to do increment operations. There are two types. First one is pre-increment and the second one is post-increment. Okay, so the pre-increment, okay, pre-increment is defined with one symbol. So let me write. So pre-increment is defined with first incrementing and later the variable name. Okay, this is the representation of pre-increment. Coming to the post-increment, first we will write the variable name and later increment operator. Okay, so this is how the representation of pre-increment and post-increment. So let me show with the example. I have declared a variable here, right? So after declaring a variable, I want to do pre-increment. Means, so let me print. Let me have printing statement. So I am giving pre-increment operator and I am giving my variable name. So what it will do, as it is a pre-increment, first it will try to increment this numeric value by adding 1. Okay, so it will increment the numeric value by adding 1 that will be printed here on the console. Okay, so let me see the output. Let me run the program. See, if you guys observe, I got 11 as a output. Right? What is happening there? First, it is incrementing the value. Later, it is printing here. Okay, so if I try to give post increment, okay, so the name itself it is saying, right, first it will first we will access the value, later it will increment, means I need to get 10 here. Okay, so let me save and let me run. See, I'm getting 10, right? So this is how the post increment and pre increment works. Okay, so in pre increment what will happen, first the value will be incremented and we can access that value, and later coming to the post increment, what will happen, first we will access the value, later it will be incremented. Okay, so what I will do means, let me create one more variable like int a and I will assign like value plus plus. Okay, and now I am trying to print a. So can anyone say the output for this? Can anyone say the output for this? Let me know. Can I know the output for this? 11. Okay, so let me check. So 10. See the symbol. What is this? Whether it is pre-increment or post-increment? Whether it is pre-increment or post-increment? Post-increment. In post-increment, what will happen? First, it will assign the value, or first we can access the value. So whatever the value is there. So first, the 10 is the value, right? So the 10 will be assigned here. later it will be incremented. Okay, and the 10 only assigned for this A. Okay, so according to the post increment, first it will assign the value, later it will increment. So that is what happening. First it is assigning the value, which is 10, and later it will increment. So if I print value now, so if I print value, then this value variable will be storing 11 because it is incremented, right? So now I will get 11, but here inside the A variable it stored 10 because first it will assign the value, later it will increment. Okay, so I hope it is clear. See, if I print value, I am getting 11, but A stored 10. I hope it is clear. Okay, so now say the output. Try to say the output. 12. Okay, so someone answered like 12. So I have two printing statements. So what will be the A value? What will be the val value? 11, 10. Okay, let me check. So let me run 11, 11. Okay, so it is pre-increment, right? First what it will do, it will increment by 1. Okay, that 10 plus 1. That incremented value, it will assign to this A. Okay, and the value is also storing 11. A is also storing 11. Okay, that is what happening. So pre-increment means first it will increment, later it will assign or print. And coming to the post increment, first it will assign or it will print, later it will increment. Okay, so that is what happens. So let me give one more example. Number is equals to some 10. I am taking 10. So try to give output for this. Okay, and later so try to give output for this. Let me know if anyone knows. Try to give output for this. I am assigned 10 to the number variable and I have done post increment and I am trying to print number variable again. So try to give output. So someone is saying 11, 10. So okay. Let me run first. 10, 11. Okay. So if you observe what it is post increment. What post increment will do? First it will assign or print. Here I am having printing statement. So it will print. Okay. What it will print? 10 it will print. Later it will increment. Okay. And the number now will be storing 11. Incremented, right? It printed here and later it will get incremented. Okay. So it will become 11. So that 11 will be printed here. Okay. So like this we can apply increment and decrement operators for the float values too. Okay. Let me give one float number like 10.5. So let me change the data type. Okay. So now, can anyone say the output for this? Now, can anyone say the output for this? Ten 10.5, 11.5. Okay. So let me check. Yes, 10.5, 11.5. Okay. So this is how pre-increment and post increment will work. Okay. Is it clear how increment operators will work? Is it clear? Whether I need to give one more example? Let me know. So you want example? Okay. So I hope it is clear. So now we will move to decrement. Okay. So like increment, decrement is also having two types. Okay. So first one is pre-decrement. Pre-decrement. Okay. So that will be denoted by minus minus and the variable name. Okay. So what will happen here means first it will decrement the value. Okay. First it will decrement the value. It will decrement the value. Later, okay, later the value will be assigned or printed. The value is assigned or printed. Okay. So the next type is post decrement. So what will happen here? How we will represent variable name and minus minus. Okay. So how it works? So first post decrement, right? So first it will assign or print the value. Okay, or print the value, and later it decrement. It get decrement. It get decremented. Okay, so this is how it works. So let me give example. So let me change only the data type here, like int. Okay, so let me give 10 only. So instead of plus plus I have given minus minus. Okay, so let me know the answer for this. So try to observe whether it is post decrement or pre decrement and try to answer. Ten nine. Okay, so let me check. Let me run. Yes, 10 9. Okay, so what is this? This is post decrement. What post decrement will do? It will decrement postly, means later. First it will assign or print the value. So as I am having printing statement, first it will try to print the value. What is the value? Number variable storing 10. So it will print the value 10. Later it will decrement by 1. Okay, that decrementing value, so it will be decremented by 1, right? Now it became 9. So that 9 again is stored inside this variable. So if I try to print this variable, I will get decremented value. Okay, this is how it works. Okay, now Now try to answer. Now try to answer. What will be the value? What will be the output? No answers? 9, 10, 9, 9, 9. Okay, so let me run first. 10, 8. Okay, so what is this? This is the post decrement. Right? What post decrement will do? It will first print or assign the value. So it will print the value. Okay, so first it will print the value. Which value it will print? 10. Okay, later what it will do? It will decrement. The value will become 9. Okay, so after coming here, so this statement, now the number variable stored 9. Okay, so it got decremented. Now coming to this, what is this? It is pre-decrement, right? What will happen here? First it will decrement, later it will assign or print the value. So first it will decrement. So now the 9 will be decremented to 8. Okay, later that value will be printed. Okay, so 8 will be printed. Okay, here 10 will be printed and here 8 will be printed. Is it clear? Is this clear? Let me know. Is that clear? Yeah. So I will repeat one more time. So what is this? What is this? So it is, so what is this? This is the post decrement. Means it will decrement postly later. Okay, first what it will do? It will assign or print the value. So as I am having system.out.println statement, first it will try to print the value. So what is the value? The number variable stored 10, right? So 10 will be printed first. Okay, later what it will do? It will get decremented. Means postly it will decrement, right? So it will get decremented. Now the value will be 9. 9 will be stored inside the number variable. So coming to this statement. So it is pre-decrement, right? First it will decrement, later it will assign or print the value. Okay, so first it will decrement. So the number variable stored 9. First it will get decremented. 9 minus 1, 8. The value will become 8. Later it will try to assign or print the value. As I am having printing statement, it will try to print the number variable which is having 8. So it will print 8. Okay, is it clear? Okay, so let me know whether it is clear for everyone. So if we work with those operators, then we will get some clarity. Okay, so try to work with it. Okay, so this is how pre-increment and pre-decrement, post-increment, post-decrement will work. Okay, this is about the unary operators. Okay, now we will move to other operator, which is binary operator. Okay, binary operator. Sorry, bitwise operator. Bitwise operator or binary operator, both are fine, but the usual name is bitwise operator. Okay, so what is this bitwise operator? When we will use? So it is used to perform operations on binary digits. Okay, so it is used to perform operation on binary digits. Okay, so what are binary digits? Zeros and ones. Okay, which is mission understandable language. Those are binary digits. Okay, so now the question is how to convert a decimal number to the binary format, right? So you think that I am having some number like 4. How to represent this in binary format? Most of the people may have this question. Okay, so the thing is, if 4 is there, if we divide continuously by 2, okay, until we get remainder has 1 or 0, then we will get our binary digits. Okay, so first let me show. First 4 divided by 2. I will divide it by 2. So if I divide this by 2, what will be the output? What will be the output? Okay, what will be the output? So I will get remainder is equals to 0, right? And quotient. Okay, so let me give quotient is equals to 2, right? Again you need to divide quotient by 2. Now what will be the output? What will be the output? The remainder, for this the remainder will be 0 and the quotient will be 1, right? If you guys observe, okay, if you guys observe, I am getting here quotient 1, right? So there is no other thing to divide by 2. We cannot divide. Okay, we need to stop here. So now from quotient, take quotient from the last and all reminders before it. Okay, so 1 0 0. So this is the binary representation of 4. 1 0 0. Okay, so this binary represented, how we will get to know whether it is 4 or not? Okay, so this is the 2 power 0 place, which is LSB bit. 2 power, okay, 0. 2 power 0 means 2 power 0. Okay, and coming to this bit, it is 2 power 1. Okay, so coming to this, it is 2 power, so 2 power 2. Okay, so this is how we will calculate the bits. So let me give some gap between them. So, okay, if you guys observe, this is how we will calculate. 2 power 0, it is represented by 0, means 2 power 0 normally is equals to 1. Okay, but here in this place I am having 0, means this is not valid. Okay, coming to 2 power 1. Okay, here also I am having 0th bit. Okay, which I should not add. Okay, coming to the 2 power 2, I am having here 1. Okay, so the value is 2 power 2 value is 4. So that will be the this will be the binary representation of 4. Okay, this is how we will do decimal to binary conversion. Okay, so what we will do? We will divide the number, a particular number, to 2 until we get quotient as 1 or 0. Okay, after getting quotient 1 or 0, what we will do? We try to add the numbers from bottom to up. Okay, this is how we will do the binary conversion. So I hope it is clear. I hope it is clear. So is it clear whether binary conversion? Okay. So now how we will do the bitwise operations. Okay. So inside bitwise operator we are having so many types. Like the first one is bitwise and the next is bitwise or and the third one is bitwise XOR, okay, and bitwise not. So bitwise not. Okay, so coming to this bitwise and, okay, first let me write the truth table. Okay, it is similar to the logical and, okay, but here in the bitwise we will represent zeros and ones. Okay, there in logical we will be representing true and false, right? So here in bitwise we will be representing zeros and ones. Okay, so 0 is nothing but false, okay, and 1 is nothing but, so 1 is nothing but true. Okay, so now we will try to write the truth table. So expression 1, expression 2 and the result. Okay, so if both the, like in the logical and, what is the expression says? If both expression 1 and expression 2 are true, then only the result will be true, right? In here also the same thing. If both the expression 1 and expression 2 are 1, then the result will be 1, otherwise it is false. Okay, so first think that expression 1 is 0 and the expression 2 is also 0. So the output will be 0. False and false, false, right? So coming to the next expression, think that the expression 1 is 0 and the expression 2 is 1. And the result will be false and true, false, right? And coming to the next expression, which is if the expression 1 is true and the expression 2 is 0, so true and false, false, so the result will be 0. So coming to the last expression, think that the expression 1 is 1 and coming to the expression 2, think that it is also 1. So true and true, the result will be true. So this is how it works. Okay, so let me show with the example how we will do bitwise and. So let me take example. So think that I want to do bitwise AND operation between two numbers called 11 and 7. Okay, so bitwise AND operator is denoted with this AND symbol. Okay, so now I am giving 7. Okay, internally what it will do means it will convert to the binary digits and it will do AND operation. Okay, it will convert this to the binary digits. Okay, and it will do AND operation. How it will do? Let me show here only. So, the binary representation of 11 is 1, 0, okay, 1, 1. This is the binary representation of 11. So, coming to the binary representation of 7. So, the binary representation of 7 is 0, okay. So, 0, 1, 1, let me write 1, 1, 1. Okay, so this is the binary representation of 7. So, to do AND operation. So, now this is the result. Okay, so what is the result? So, we will be doing AND operation from the LSB bit. Okay, this last bit is the LSB bit. So, we will start operation from LSB bits. Okay, so 1, 1. What is the output? True and true. What is the output? True, which is 1. Right? Coming to here. So, true and true. What is the output? True. Right? So, coming to here. Okay, true and false. What is the output? False. Right? So, coming to here. True and false. What will be the output? False. So, this will be the output. Okay. This is how binary AND operation will work. So, if you see here, so this is the 2 power 0, 2 power 0, okay, 2 power 0. So, let me calculate. So, 2 power 0. So, we know, right, 2 power 0 is equals to 1. So, 2 power 0 and this LSB bit is 1, right? So, into 1. Into 1. So, this 2 power 0 is 1. 1 into 1, 1. Right? So, next plus, this is the 2 power 1 bit. Right? So, 2 power 1 and into this value is 1. So, 2 power 1 into 1 plus 2 power 2 power 2 power 2. 2 power 2 into the bit here it is 0. So 0 and plus, okay, 2 power 3. 3 into what is this bit? Last bit 0. Right? 0. So 0. Okay. So 2 power 0 means 1. 1 into 1, 1. Okay. 2 power 1 is 2. 2 into 1, 2. 2 plus 1, 3. Okay. Totally, this expression will become 3. So, coming to here, 2 into 2, 2 power 2, 4. 4 into 0, 0. Okay. 3 plus 0, 3. Coming to here, 2 power 3, 8. 8 into 0, 0. So, here this expression is 3. Okay, this expression is 0. This expression is 0. So, 3 plus 0 is equals to 3. Okay, so this will be the output. Okay, so let me run. So, see here, I am getting 3 as a output. Okay, this is how bitwise AND operator works. So, I hope it is clear. I hope it is clear. So, let me know. Okay. So, others, try to respond in the chat box whether it is clear or not. Try to respond quickly. There is no time. Try to respond quickly. Okay. So I will give brief explanation. So this is the binary representation of 11. Okay. So to get the binary representation, try to divide this 2 until you get quotient as 1 or 0. Okay. So then you will get this binary representation. Okay. So this is the binary representation of 7. Okay. So this is the result of this 2 AND operation. Okay, so for a bitwise AND operation, this will be the result. So always we will start the operation from LSB bit. If you observe, this is 1, this is 1. 1 will be represented as true, right? So true and true. What will be the result? True only, right? As I shown in this expression. 1, 1, 1. Right? So, coming to here. So, again 1, 1. 1 and 1, the result will be 1. So, coming to here, 0 and 1, the result will be 0. So, coming to 1 and 0, the result will be 0. Okay. So, this is the result we got. So, how to convert this binary to decimal? What you want to do? This is the 2 power 0 bit. This is 2 power 1. This is the 2 power 2. This is the 2 power 3 bit. Okay. So 2 power 0, what result we got? 1 into 1. So here coming to this 2 power 1 here. This is 2 power 1 bit. 2 power 1 into 1. This is 2 power 2 bit. 2 power 2 into 0. Okay. So this is 2 power 3 bit. 2 power 3 into the result is 0. So try to add all this. Then you will get your final result. I hope it is clear. Okay. That is how it works. So coming to next, which is bitwise OR operator. Okay. So let me write the truth table first. So expression 1, expression 2 and result. Okay. So think that the expression 1 is 0. Okay. And the expression 2 is 0. So as I said, 0 means false, right? In logical OR operator, okay, in logical OR operator, how it will work? If any one of the expression is true, then the total result will be true. Otherwise, it is false. So here also the same concept. If any one is 1, if any one expression is 1, okay, then the total result will be 1. Otherwise, 0. Okay, so here expression 1 is 0 and expression 2 is also 0. So the total result will be 0. Right? So coming to the next. So think that the expression 1 is 1 and the expression 2 is 0. Okay, then I said, right, if any one expression is 1, then the result will be 1. Okay, coming to the next. So think that the expression 1 is 0 and the expression 2 is 1. Okay, then the result will be 1. And coming to the last expression, think that this expression is 1 and this expression 2 is 0. So the total result will be 1. Okay, this is how bitwise OR operator works. Okay, let me show with the example. The same concept but OR operator. That's it. So So let me take some two numbers like 15, okay, and 7. So how we will represent the OR operator? We will represent the OR operator by this symbol. Okay, so this is the symbol to represent bitwise OR operator. How this works? Let me explain. Okay, so first internally it will convert the 15 to binary digit. Okay, the binary representation of 15 is 1, 1, 1, and 1. Okay, so internally it also converts 7 to binary representation. So what is the binary representation of 7? 0. Okay, 1, 1, 1. This is the binary representation of both 15 and 7. So what I want to do here? I want to do OR operation. Okay, so what will be the result? What will be the result? So the result will be, always we start operation from LSB bit. So 1 or 1. What will be the result? What will be the result? 1. Okay, expression 1 is also. So I missed some. Okay, sorry here. So I missed the expression. So 1. Here 1. Okay, I wrote the same expression 2 times. So 1. Okay, expression 1 is 1, expression 2 is also 1. So the result is 1. Right? So here the same thing. So here also expression 1 is 1, expression 2 is 1. The result will be 1. Coming to here, the expression 1 is 1, expression 2 is also 1. The result will be 1. Okay. So here also expression 1 is 1, expression 2 is 1. The result will be 1. Okay. So coming to here, the expression 1 is 1, but the expression 2 is 0. So we know in our operator how it works. If any one expression is true, then other expression, we won't care about other expression. The total result will be 1. Right? So that's how our operator works. So here 1. Okay. So how we will convert this binary representation to bit decimal? How we will convert? We know that this is the 2 power 0th bit, right? So 2 power 0 into, what is the result we got? 1 plus, next what is the bit? 2 power 1 into, what is the result? 1. And the next bit, what is the bit? 2 power 2 into, what is the result? 1 plus 2 power 3 into, what is the result? 1. So this will be 1. 2 power 0 is nothing but 1. 1 into 1, 1. So 1 plus 2 power 1 is equals to 2. Right? 2 into 1, 1. Okay. So 2 into 1, 2. Right? So 2 plus, so here this, let me write. So this expression will become 1 into 1, which is 1, plus 2 power 1 is 2. 2 into 1, 2, plus 2 power 2 is 4. Right? 4 into 1, 4, plus 2 power 3 is 8. 8 into 1, 8. Okay. So if we try to add this, we totally get 15 as output. Okay. So let me try to execute this. So I'm getting result as 15 only. Okay. So this is how OR operator works. So I hope it is clear. I hope it is clear. Let me know, reply fast. Okay. So In the same way, the OR operator also. So coming to the next, which is OR operator. So XR operator. Okay, so expression 1, expression 2, result. So in logical operator, we are not having XR operator, right? So here, how XOR operator works means, if two expressions are 0, like expression 1 is 0, expression 2 is 0, then the output will be 0. If the expression 1 is 1 and the expression 2 is also 1, then the output will be 0. Means if the two expressions are having same values like 0 or 1, there's two expressions are having same value, then the result will be false, uh, which is equals to 0, otherwise it is true. Okay, so let me write the expressions. So think that expression 1 is 0, expression 2 is also 0. So where the two expressions are same, having same value, so the result will be 0 only. Okay, next, think that the expression 1 is 1 and the expression 2 is also 1. Okay, here also expression 1 and expression 2 are having same value, so the result will be 0. Okay, if both expressions are same, the result will be 0, otherwise 1. Okay, so think that this is 0 and this is 1, the result will be 1. Okay, so think that this is 1 and this is 0, so then the result will be 1. Okay, this is how XOR operator works. So let me show with an example. Okay, so I want to do XOR operator between two values like 2, and XOR operator will be represented with the help of this. Okay, which is like an arrow. Okay, so coming to the, I want to do XOR operator between 2 and 7. So how it internally works? The same way. First, it will convert to the binary representation. What is the binary representation of 2? 0, 0, 1, 0. Okay, so coming to the next, what is the binary representation of 7? 0, 1, 1, 1. Okay, how XOR operator will happen? What will be the result? We will start from LSB bit. So here both expressions are not same. Then the result will be 1 only, right? Coming to the next. Here also, if you see, both the expressions are same. If both the expressions are same in XOR operator, the value is 0. Coming to here. Here both the expressions are not same. So the value will be 1. Okay. So coming to here, both the expressions are same. If both the expressions are same, the value will be 0. Okay, so now try to add this. Try to convert this to decimal. So you know, right? So how to convert this to decimal? 2 power 0 into 1. Okay, which is equals to 1. Okay, which is equals to 1 plus, this is 2 power 1. 2 power 1 into 0, which is equals to 0, plus this is 2 power 2. 2 power 2 into 1, which is equals to 2, right? So plus this is 2 power 3. 2 power 3 into 0. So sorry, here 2 power 2. 2 power 2 means 4. 4 into 1, 4. Okay. So coming to here, 2 power 3. 2 power 3 into 0, which is 0. Okay. So 1 plus 0 plus 4 plus 0 equals to 5. Okay. So the output will be 5. So let me save and let me run. See, I am getting 5 as the output. Okay. This is how the XOR operator works. So I hope it is clear. I hope it is clear. Let me know whether it is clear or not. Okay. So coming to the last, which is bitwise not. Okay. So bitwise not is nothing but it is like a opposite, right? So think that the expression is like 0 0. There is one number, I have converted that number to binary digit like 0 1 0. Okay, what bitwise not will do, it will convert to opposite digit. If it is a 0, it will convert to 1. If it is a 1, it will convert to 0. Okay, so if you guys observe here, the first bit is 0. It always starts from LSB bit. So first digit is 0. So the digit will be 1. So first later the digit is 1. So opposite to that 0. The next 0. 0 means 1. Okay. So coming to this 0. 0 means 1. Okay. But the thing is, if I take any number, it will convert to 32 digit bit. Okay. This is 4 digit bit. Okay. This is 4 digit bit. So while doing bitwise not operation in Java, it internally convert it to 32 bit. Okay, so that is the reason we will get different output in negative values. Okay, most of the times we will get negative values because internally it will convert the number, a particular number to 32 bit. But here, while doing AND operation or operation, what we are doing, we are converting a bit, a number into 4 bit. Okay, but while doing bitwise not operation, Java will convert the number to 32 bit. Okay, so which leads to get negative values. Let me show with the example. So let me do OR operation between 11. Okay, so the not operation bitwise not is represented by something. So 11. Okay, so I want to convert this to bitwise. I want to apply bitwise not operator. So the bitwise not operator is represented with the help of this symbol. Okay, so internally what it will do means it will convert this number to 32 bit. Okay, which is 32 bit, not 4 bit. It will convert it to 32 bit and it will get the result. So let me save and let me print. Sorry, let me print on the console. So if you observe, I am getting a negative value. As it is converting into the 32 bit, we will be getting the negative value. Okay, so let me try to apply this not operator on 7 2. Okay, so let me run. See, I am getting -8. Okay, so this is how it works. I hope it is clear. So is it clear how the bitwise operators works? Let me know quickly. So any doubts in today's class?